Hello everybody, my name is Sheep and today we'll solve problem 45, Jump Game 2. This is part of the top interview 150 study plan from LeetCode. It's a medium problem, so let's get into it. You are given an integer, oh wait, no, you are given a zero indexed array of integers, nums of length n. You're initially positioned at num0. Each element nums I represents the maximum length of a forward jump from index I. In other words, if you are at nums I, you can jump to any nums i's plus j, where 0 is less than or equal to j less than or equal to nums I, and I plus j is less than n. Return the minimum number of jumps to reach nums n minus 1. The test cases are generated such that you can reach nums n minus 1. That's a relief. And we can look at example 1 over here. Ooh, we can jump from, say, 2 to 3, and index 0 to index 1, and then from index 1 to 1, 2, 3, straight to the last index. Right, example 2 is similar. Yeah, the example 2 is similar, and we look at our constraints. That's good. Now let's discuss our approach. We can jump. We can jump from. Okay, we'll check each steps, right? We'll check the maximum number of like steps that we can jump from at every element of the array at every index, and then we'll see if with the maximum with the maximum length, with the maximum jump length of each index, we can get to the final index, right? Does that make sense? All right, I hope. Okay, let's try to code that, and it would probably make more sense after that. The basic idea would just be to calculate the maximum jump length at every position, and then see whether or not with those maximum jump length we can make from the first index to the last index. Okay, so for equals 0, I less than num size, I plus plus, we'd say our destination would have our destination equals our I plus nums I. Right? Oh, but what if I plus nums I exceeds nums size, right? Exceeds the size of nums, which is our last index. That means we have to kind of like prevent that from happening, or else our program will crash. We'd say the minimum of I plus nums I and nums size minus 1. So there we go. And for each step, we'd have our maximum, an array that stores the maximum jump length at each position. Let's call that um, max each. Yeah, max each. And have that 0, right? 0 at first. The maximum is 0 for everything at first. And we can say for int j equals I plus 1, that is the next index from I till j is smaller than or equal to our destination. That is the last index that we can get to, from the furthest index that we can get to from I, and increment j, right? So with each of these steps, we'll check max each, right? Max each of j would be equal to the maximum of max each of j and j minus I, right? Yeah, would be that. And then we'd come down here and we'd say index. We have an index that starts at 0, or as a matter of fact, we can jump from the first index to the last index, or we can jump from the last index back to the first index. I'd like to jump from the last index back to the first index just to see what happens. And while our index is larger than 0, which is we haven't reached our first index yet, and the max each of our index is not 0, which means if it is 0, then it means we cannot make a jump anymore, right? So we'd like to get out of this while loop. So if that's so, then our index would equal to our index minus the max each index, right? Yeah, and we can have the number of steps, that it would take us to jump. So the number of jumps we'd make, more so to speak, and then we'd return that count. Okay, let's run our code. Uh, oh, what's happening? Oh, okay. Yeah, we missed that. Yeah, and seems to work fine. So let's try to submit it. There we go. So that is our code.